So I did send out a message on this earlier today, but so as most of you know, I did finish grading the first module. And for the most part, you guys did awesome. Well done. Few of you I had to sort of send back for revisions and things like that, but that's fine, right? That's kind of what this is all about. Um, and again, just a reminder, you can submit as often as as often as your heart desires. um, you can sort of resubmit, and that's again with the design to make this more of a conversation. So if you weren't able to get something done or you accident input something incorrectly, it's very easy for us to be like, hey, let me sort of send it back. If you want, you can take another pass at it, send it back. We can kind of get your grade to where we you want it to be. That's always the hope and the goal with those things. Quick flag. I know I sound like a broken record, and I'm so sorry if you've been on top of this. But again, just a quick reminder, if for the collab notebooks, you always have to share. Don't just copy the URL directly here. Let me share screen. So don't just sort of like copy the URL directly because that's not going to work, right? If you've done anything with Google Docs before, you will know um, that's access restricted. You go to the big share button here, pop that up, change the permissions. So right now you'll see this is changed to restricted. Only people with access can open link. Change it to anyone with link, then copy that link and then that's what you submit. I know, again, I apologize. I know I'm sounding like a broken record on this, but uh yeah, a solid minority of you are still submitting it the original way. So yeah, so if you would be so kind as to submit that way, it makes it a little easier for me to grade and things like that. Um but yeah, any questions in terms of like the logistics of submitting or anything like that? One of the things I want to, just kind of take stock, see how the class was doing. One thing I sort of mentioned, uh, a number of you haven't necessarily had a chance to submit anything, particularly for module two. Oh, wait a second. I want to hang on. If it's not I want a meme I want to show you guys. It's very relevant to us. Oh man, where is it? No. Hang on. Sorry. Uh, Okay. Yeah, this is pretty much it. Okay, this is okay. You ever hear the expression, if it's not the due date, it's not the due date, as in DUE versus DO? All right, so if you guys know, this is the burnt out senior due tomorrow, due tomorrow, right? But okay. So my point being that right, this class has flexibility for a reason, and I want you, and I've stressed this from the outset. I want you to have flexibility to submit. It's not a problem getting in late. But having said that, right, I never want it to be I don't want it to be a sign of potential problems of folks maybe falling behind. If you're just prioritizing some other classes or some other work or things like that, and you're gonna knock it out and you're pretty confident you can get it, like that's fine. Like no concerns. I'm certainly not going to be sitting here sucking lemons that you didn't do my homework first. Um, but again, I just, just because the numbers were particularly stark, I do try to kind of keep track of where folks are in most of my classes, and people, for the most part, do a reasonable job keeping up. We were lagging a little bit, and so I just wanted to be like, okay, before we kind of close the book and object-oriented programming, I did want to give you guys sort of a little extra breathing room to kind of get caught up with things before I kind of pushed out new content, new material, new things like that. So that was a reason why I sort of made the decision because I'll be honest, we do still have one more topic, and I think it's a really cool topic, and it'll probably take us realistically at least an hour to talk about. Um, but before we kind of moved on to module three, which we theoretically could have, I did want to, again, give you guys a little extra time for that. So, in that spirit, again, we're going to wrap up object-oriented programming tonight. We're going to talk about the module, the lab three for it, and then sort of I'm going to give back some time and again, just kind of make sort of layer in an additional office hour. So again, if anybody does have any questions, is struggling with any of the assignments, I want to just kind of stick around and make sure you guys have the support you need. So if not, then you can have a slightly earlier night tonight. But yeah, that's my plan for tonight. So in that spirit, before we dive in, talk about what we're going to talk about, any questions? All good. Okay, so last major topic for object-oriented program. Thank God we are almost done. And by the way, I will say this, coming up next after this one is and by the way, is I think um with spring break for us is in 2 weeks, right? It's not next week, it's 2 weeks from now, right? I should know that, but I think it's mid-April. So we have one more lecture before spring break. Because normally I'd get through module three before spring break. Maybe I'll still do it because it's kind of quick. We'll see. But I will just say this: module three is going to be a nice, what I call a palate cleanser. Because again, module two was the most conceptually difficult material we cover in this course. As you sort of saw, right? We went pretty deep, um, in terms of sort of thinking about sort of the theoretical underpinnings of some of the stuff we did here. Not necessarily a whole lot of practical applications in terms of programming, but again, there is sort of a lot of theory that sort of underlies, I think, things that we do. So yeah. So again, I know it's a lot. I know, didn't want you guys to burn out. And so sort of deliberately, I programmed the most boring possible module after this, and that's standardization and best practices. Um, just completely, I mean, just God, I like I appreciate that there are people in this world who enjoy that sort of thing and do it, and God knows we're probably better off for it, but just bullet to my brain. It is not a good time. I mean, it is just like, how many spaces do you indent with? And do you capitalize your functions versus thing? And it's all those like okay, fine. Again, I get it. Sure, there's utility in it, but my God, just yeah. So we're deliberately sort of gonna be doing that next week because again, just wanna just wanna sort of um give us a little bit of a break, give us a chance to refresh things like that. And then again, after sort of spring break, I think we start getting into the application side of Python, what I call the utility belt part of this course, where it's really about sort of building out skills for you. So immediately after that, we're going to get into graphical user interface programming in Python, how to actually build, again, applications that are user friendly, right? That you don't need to have your entire interface be limited to terminal, but you can actually make beautiful interfaces with drop down menus and input forms and buttons and things like that, right? Those can all be encoded in Python. So yeah, so that's coming up afterwards. After the break, after the spring break, we come back, we get to have some fun with that. But all right, let's do some encapsulation, shall we? So, um, and I'm going to sort of say this up front. Encapsulation, so a lot of the conversation we've been having around object-oriented programming, again, one of those themes where very useful, obviously, in the context of Python, but also incredibly useful as you continue your programming journey. So, again, because a lot of sort of themes that a lot of ways in which we think about, we organize, we structure our code in Python also, we just naturally do it in most other object-oriented programming languages. So Java, JavaScript, C++, you name it, all those sort of, the heavy hitters all sort of follow similar design principles. And so, again, so a lot of the conversations we're having around Python and object-oriented programming are very, very applicable as you hopefully continue this journey, right? So, in that spirit, useful for Python, but even more useful, again, if you decide to take a Java class, you decide to do that because all these themes do carry over. So, um, encapsulation is one of those things, and you'll see why in a moment. I'm sort of talking about this. It's a major thing in object-oriented programming. It is kind of a wiggly thingy in Python itself, and we'll see what I mean by that in a moment. But let's sort of talk about this. So, if you think about the literal word encapsulation, right? It's a fancy word, but think about like a pill, like a capsule, right? To encapsulate something is a verb to basically stick it in a little, to sort of self-contain it, right? To sort of entrap it, to enclose it, to right. We're putting our little vocabulary here to getting it to the test, right? Anyone else got some good thesaurus definitions we could throw up there? Throw it up in the chat if you want to. But right, to encapsulate is to enclose it within sort of a controlled environment. And so, we have already we've already sort of seen this idea of classes basically encapsulating methods and attributes and things like that, right, as an organizing principle. But what we haven't talked about is encapsulating it not just from an organizing principle, not just a nice way of, again, sort of assembling methods and attributes and things like that in a way that's sort of um, intuitive and clean and things like that. But what we haven't explored is the idea that that encapsulation can also serve to restrict access and specifically to prevent accidental modification of data. And so it's right. So right now, so let's go back to, so I have our little thing here. So right now, we have, right, we have, again, so I'm just going to belabor this whole class thing, right? So we got our little player class here. We already, and this class now we can sort of see we have object level attributes. We have class level attributes. We have, right, we talked about in the past, we have object level methods. In this case, define, wound, heal. We have class methods. In this case, right, the change game that updates the game attribute to the new one. And then we have static methods, right, that are sort of utility methods that are organized within the class but don't necessarily impact any aspect of the class directly, right? So that's kind of a quick thing there. Now, you may remember, sort of as part of that, here, so let me copy this. Is there an easy way to, is this the copy? Mirror cell and tab? No. Is there an easy, okay, here. Well, let me just grab this. Go all the way down here. All right, and then I'm going to sort of add someone. Okay, so what is our constructor for this? Okay, we just need a name. Okay, so I'll just initiate with Ian. So Ian is a player whose name is, oh, player. Oh, player. Yeah, capital P. Fair enough. All right, there we go. And so, we've talked about kind of this idea of like these getters and setters, right? The ability to update. So for instance, I can wound Ian, right? Well, firstly, let me look at these attributes, right? So I can do Ian define and get that information. So his current health is 100, but I can also reference that attribute directly. I can say Ian health and just get that attribute directly, right? And I have the ability now um, to wound Ian. My apologies, Ian, in advance. Let's see, I'm going to give you 20 damage. And then if we look at your health is down to 80, right? So I can use this, I can use a getter, an official method to get it, but then I can get the attribute as well. I can use a setter method to modify an attribute, but I can also just say 100 and just get you back to full health. And sure enough, you're back up to full health, right? So, um, so up until this point, we've sort of had the ability to organize these things, we've had the ability to modify it, but we haven't necessarily had the ability to control access to these things, right? So in this case, I can reference iron.health is a global variable. It's fully accessible within the entire program. And one of the big things encapsulation potentially does is it gives us the ability to control access. So right now we have this default state where it's publicly available. Again, it's treated like a global variable. You can kind of do whatever you want with it. But theoretically, encapsulation allows us to control and to restrict how you access and modify data within a class. So that's kind of the interesting sort of new additional nuance that we're putting on class data than we had before. Now, why am I doing this sort of hand wavy thing with Python? So remember, this was another theme that we kind of broached. I think we talked about. I know last week. I don't know that we talked about it the week before, but this whole idea that remember how sort of one of the themes we've had with Python is jack of all trades, master of none, right? That's kind of been an ongoing thing with us, where Python is great. You can pretty much do anything with Python, but you can't necessarily do everything exceedingly well. And that's just because Python is such a general utility language. It's great across the board, but as a result, some very specific functionality kind of gets by the wayside. And this is an example of this. So, so the nuance here is that Python support, and I'm literally going to give you the text. I didn't write this. I literally grabbed this text from some source documents because I love the way they phrase this. I love the language around this. So they say Python supports encapsulation as a design principle. So in other words, Python doesn't actually do encapsulation the way we think about encapsulation as an object-oriented programming language, right? You learn Java, like it's strictly enforced. It's a thing. Python, not so much. A design principle says we can write our classes in a way that suggests at encapsulation, but, and I love the verbiage for this, it does it in a very consenting adults way. So in other words, that means we sort of have specific naming conventions that try to give us um, sort of the characteristics of encapsulation, but Python itself does not support actual encapsulation. So again, you look at other languages that are maybe a little bit more that embrace the the full capabilities of object-oriented programming. They have these capabilities. Python does not. So again, so please note when I'm talking about in a moment we're going to talk about like the syntax and the things for these things. Um, Again, please note that this is a design principle, and I'll show you an example of what I mean by that because again, there is a way to kind of get or circumvent these things. These are not actual sort of hard-coded programming elements of it. So, yeah. So again, Python, right? It's you get the good with the bad. So let's talk about kind of what it actually means for something to be hidden. Okay. And by the way, we already have a little bit of a kind of a framework for thinking about this because when we learned functional programming in Intro to Python, we learned about the difference between global and local variables and the associated scope. So, okay, pop quiz. Anybody can tell me what's the difference between a global and a local variable when it comes to, say, functions? Anybody? Nah, we're chilling tonight. Okay, so you may remember, right? So again, so we have, right, generally speaking, sort of two ways we think about variables. So let's say we have, again, greeting equals hello. That's a global variable, right? It's in our program. It's there. It's universally accessible across programs, things like that. I can also do a, you know, def print greeting. I'm going to say uh, greet equals hello there, print greet. Okay. So now if I run this, now, or so I can execute this code, right? I can execute print greeting. I'll say hello there. But if I try to grab greet, you may notice already it's not in our little sort of variable thing. It's not in our environment. If I try to access it, again, it doesn't exist, right? Because again, this is an example of a local variable. It's defined within the scope of the function. And so within the function, you can access it, you can manipulate it, you can do all the things that you would normally do to variables, right? Access, modify, read, manipulate, all those things within the scope of the function. Outside of the scope of the function, we're not able to. Right? So that's the difference between a global versus a local variable. Y'all with me so far? All right. So applying that to sort of classes, we can sort of think about we can sort of think about data access kind of in that way. So and generally speaking, there's three methods. There's three ways in which we can sort of think about data access. They are public, protected, and private. So first up is public. So this is kind of what we've been dealing with up until this point. Public data easily and universally accessible from any part of the program. Again, all data attributes and methods of a class are public by default, right? That's sort of what we've, again, sort of seen here, right? So iron health, just right, as an example, that's a publicly accessible thing. I can access it, I can manipulate it anywhere within the scope of a program. Yes, I can use a getter and setter, but I don't need to, right? Because it's a global variable. So that's public. Private, in contrast, are accessible and modifiable only within a class. And so the private access modifier is considered the most secure modifier. Data members of this class are declared private, by the way, by adding a double underscore symbol between the data member and that class. So again, you may notice here, so that so this little cheat sheet here, double underscores indicates it's private. And again, private things are not accessible and modifiable outside of the class. So let's just kind of see an example of that. Let's call it. So let's modify. Let's take this. So let's make job. Let's make job a private. Yes, let's make job a private one. Let's reinitialize this. Reinitialize that. So now, if I try to grab, so if I try to grab health, right, I can do that. If I try to grab job, I cannot. And interestingly enough, if I try even just do that, it won't work either. And I'll tell you a little bit why about that, because that actually gets, if you really want to get in the weeds on that, that's kind of an interesting little thing there. It has to do with like name mangling or whatnot. I think I do it. I think it's, wait a second, let me see here. Let me see if I remember the syntax on this. I may, yes, okay, cool, I got that. Sorry, that was louder than it should have been. I'm sorry. Okay, I'm going to tell you what that is. I'm actually really happy I remembered the syntax for that. Uh, that's a whole idea of mangling. Yeah, I'm sorry. I had a cold brew this afternoon. I apologize. But okay, right. So again, if I try to access directly, I cannot because theoretically it's private. Protected attributes are what we consider restricted outside of the class entirely, but accessible to other classes through inheritance. And so the idea is that, again, like if you think about our inheritance previously, so it's the idea that sort of subclasses can access and potentially modify those attributes as well. So they're still encapsulated, but they're encapsulated within the bonds of inheritance and extension. And again, sort of a protected class has one underscore. So here, let me show you something here. So if I change, let's say power to be that, I know, let me just define this again. Oh yeah, that's not gonna work. I'll have to fix that in a moment. So again, so now if I try to get power, It doesn't work, but I do that. Oh, it works. So it's a naming convention. Right. So, and I need to tell you about kind of what's going on. So I'm going to come back to what's actually going on there. I just want to, again, for now, I want you to kind of get the idea of what's going on here from a theoretical perspective. And then I'm going to talk about like the reality of Python. Because remember, Python's actually broken. Python doesn't actually do this. But this is a very real object-oriented programming thing. So again, take Java, like this is a thing, and you will absolutely want to know this and differentiate because this is hard coded. So again, public, right? That's what we've been doing with up to this point. Completely accessible, everything's good. Private, not accessible at all, right? So I cannot access it, I cannot modify it, I cannot do it. Right? Even if I tried to, I couldn't theoretically do it. Protected, theoretically, you're not supposed to be able to access it outside of the program or outside of the class, but within the class and its descendants, you can access and you can manipulate it. Okay, so that's kind of the conceptual framework we want to go with that. So you might say, okay, well, if going back to those whole private things, if those are restricted, then what good is it? Like what good is having a private attribute that I can't actually do anything with, right? So, turns out there is a way because I can theoretically sneak information out by defining a class method to do so. And so remember when we were talking about kind of getters and setters, right? The idea that again, a getter allows me to return information and a setter allows me to modify it. So with private data, now that really is actually the only way to do that. Um, and so for instance, so now job is here. If I do that, and let me fix power as well, do that, do this. So again, if I try to get iron power, it's not going to work. Try to get iron health. What? Wait, no. Oh, job. Sorry, job is the private one. Sorry. Job, that doesn't work. But if I grab the define method, look, I get the job, I get the power. I got the power. Right? So this getter method theoretically allows me to sort of bypass the restriction that I have. And again, same thing with the setter, right? So theoretically, I can't change. Again, I can't say Ian's job is actually assassin, right? I can't do that. That shouldn't have worked. Did that work? Job healer. Okay. So no, so it didn't work. See? Okay. Oh, interesting. Wait a second. I want to see something here. Oh, that's funny. Okay. Okay, here's what it did when I did that. Um, it it created a brand new attribute and then like sent its value. So this is Python's worthless. Okay, whatever. Theoretically, it shouldn't have been able to modify that, right? I mean, if you look at this, the original sort of power thing is still, the original attribute is still healer. But what I could do is within this little thing here, I can say def, what am I going to say this? Change job. Self, that new job. Yep. Okay, perfect. Now let's run this again. Let's initialize you here. Okay, so right now your job is that. So now if I say change job and now I make you a paladin. Now I get you here. Now I've updated it to be a paladin. So again, setters, right? So within a class, you can use getters and setters to control how information is returned and how information is modified. So if you were working with a normal object-oriented programming language, that would be a very cool, very useful sort of restriction, right? You can sort of think about a lot of examples there. Like for instance, with the ATM method, right? When we had the ATM right now, yes, we had all of those things for controlling how you deposit and how you withdraw, but there was nothing that was theoretically stopping a hacker from just getting in and directly modifying the account balance, right? There was nothing that prevented them from doing that, at least from a Python security perspective. But however, if I made the balance a private method, or private attribute, sorry, then theoretically the only way in which that could be modified would be using the withdrawal and the deposit methods. And again, then I would have the right checks to make sure that, like, again, the person couldn't withdraw $1 billion, the person kind of couldn't do that. All that would be good, right? So you can sort of see the utility why having the ability to control how these attributes are accessed, how they're viewed and how they're manipulated is a really, really cool capability that object-oriented programming gives you, right? Because up until this point, when you thought about data, thought about variables, we've basically had just global and local in the scope of functional programming, but we haven't really had the mechanism to control and to secure data within our programming environment. And object-oriented programming, for the first time, kind of gives us the ability to control that. So yeah, so really, really cool kind of concept. But again, as you've sort of already seen, Python, not so much with that. Okay, so before we kind of get into a little bit more of like how and why Python breaks everything, um, any questions on encapsulation, again, as a general principle? No questions? Okay. But yeah, so hopefully you kind of guys see the utility. You see why this is like such a cool idea. How, again, like there was a lot of really cool programming applications for precisely where being able to control the scope and the access of certain attributes is just really critical from a programming perspective. Um, and yeah, so, but yeah, again, so, okay, so let's talk about like what's going on with Python. So one thing to know here. So restrict, so protected, or unprotected is one underscore. Protected is a purely conventional thing. So it's a pure convention. And what I mean by that is, so here, so again, so right now we have, here, let me just, so this is going to be, let me just modify, so I say this is, so this is public, this is private, and then this is, I'm gonna make these nice and orient aligned. This is protected. Okay, so again, let me just find this. Okay, so your power is protected. So again, so like theoretically, I shouldn't be able to access ion power. It says, oh, it's not defined, right? There's no thing. But if I just do that, it works. So again, so that's a pure, and I can modify it too. I can say, oh, ion's power is actually 10. And then here. So basically it's just, so that's a pure design convention, right? Purely design convention. There's nothing that actually stops anybody from modifying power directly. I just made a one underscore to try and mask it a little bit, make it a little bit more difficult, or more accurately, maybe sort of to, again, consenting adults, right? Basically saying, hey, I want this treated as a protected attribute. I don't want anybody just kind of going in and doing it. But as you can see, there's nothing realistically that stops me from doing that. Now, double underscore is a little bit different because actually something interesting is happening here with double underscore. Double underscore actually is changing the actual attribute thing. It's a process in Python called mangling, where the name actually gets changed. The variable reference gets changed at compile time. And so what I mean by that is, so again, so here if I go to job, so again, so job doesn't work. We sort of already know that, but it also doesn't work if I directly reference it with two underscores. See, it says no underscore job. Because what's happening here is that this is being mangled. Again, mangled just says that when Python is being compiled, it's changing the name of the attribute. But the thing is, we actually know what it changed to. That's what I got all excited about before. The specific pattern that it uses when it gets mangled is one underscore uh, class, two underscores attribute. I believe that's it. I'll find out in a moment. So in this case, because the class is player, if I want to access it, I can say one underscore player, two underscores job, and let's see, does it work? And that gets me it. And by the way, and so I can still modify this. So I can say you are, so Ian, you are now a warrior. If I do define here, your job is a warrior. Power is 10, current health is 10. So again, I still have the ability to modify this. The only thing that's happened is Python has mangled this thing. When it's compiled it, it changes when you do the double underscores, it mangles this attribute name. It doesn't just use job, it converts it to a class attribute syntax. But again, right, if you know it, which now we do, you could just as easily just modify the attribute directly publicly. It's still publicly accessible. There's nothing that actually restricts it in any meaningful sense. It's just, again, it's, again, going back to it, it's a design convention, right? It's Python's, it's, if you're developing in Python, you're saying, hey, please, pretty please, hackers, don't modify my job attribute because I want it to be private. But yeah, consenting adults. Um, okay. So questions on that. So questions on, again, encapsulation generally. Questions on Python's sort of specific quirks around that. Nope. So I'm feeling good with all that. We're an agreeable bunch tonight. All right, so that those were all sort of the topics. So, boy, we've come a long way from our humble origins in classes. When you first learned about that in chapter 10, did you think we were going to get anywhere near this, right? We start off with this very nice sort of thing of have this template and you can create specific objects, and we sort of introduced the idea of class level attributes, class level methods. We looked at inheritance, extension, polymorphisms. We looked at, what else do we look at? And now, of course, encapsulation. So these are all, again, sort of critical enablers and critical functionality that as you get into more advanced sort of coding constructs, they really, really come into play. And we do use this in Python pretty heavily, particularly as an organizing principle. Because again, one of the things, I'll talk a little bit more about one of the great utilities of classes in Python. But again, from a fractal standpoint, right? We've This ongoing theme for us has been how do you scale? And we talked about how classes were sort of a key enabler for that. And how, again, we sort of even saw examples of how you can sort of make root classes and then you could extend them, right? So you have a base class player, but then within that, you could sort of make specific subclasses that inherit general characteristics, but then you have the ability to scope out individual things. And you have the ability to sort of customize and tailor specific elements to it. And that's sort of being a key, again, organizing principle that really allows you to be able to structure and scale really advanced concepts within the Python framework. The other thing that is really, really useful is the ability to import these things as well. So, one of the things that we'll see, so next, one of the things we're going to talk about in module 3 as part of best practices is the idea of again, creating your own libraries and importing that, right? That's going to be sort of the next layer of scaling that we're going to do, which is we're going to begin to migrate from one big Python file to a series of sort of complementary files that all come together. Ultimately, you'll sort of have a root main file that imports elements as needed from these respective files and then kind of executes them on demand. And how useful it is to, particularly if you have a bunch of functions and attributes and things like that, how useful it is to encapsulate that within a class, import that into your main thing, and then you can just kind of, as part of the import statement, you get access to all of these elements. And so it really becomes sort of a key enabler for modularity as well, because this is a really, really great way of sort of bundling up all of these elements in a way that makes it very easy to export and carry over into other files. So that is module two. Any questions for me? All right, while you're pondering that over, last thing I wanted to make sure we covered tonight is I did want to review our lab exercises. We started looking at that already, and I will look at where is my module three? Yeah, module two, part three. Okay, yeah, this is us. So I will quickly look through everything else, but I did want to look at this. So this is the lab three thing. So you may remember here we have a series of exercises. We had the things around decorators. So again, remember our little decorators things? The idea we have this wrapper that sort of takes a wrapped function, sorry, a decorator that takes a wrapped function, uh, wraps it, extends its functionality, and then returns that, right? And so the first thing you're going to do here, if you haven't started on this, is again, you're going to define your ultimately your wrapped function, meatball, or your decorated function. Takes no inputs and then just simply prints, I lost my poor meatball when someone sneezed. And you'll find an overall decorator function called spaghetti that takes in a function as an input and then has a wrapper function that then prints on top of spaghetti all covered in cheese, ends with and does the same, right? It prints same line and then invokes the function to do that. So and then you sort of and then you do the decorator. You do the shorthand decorator so that when you invoke meatball directly, it is now decorated. Right. So that's sort of the first thing we're doing. And then we played around. You may remember this from last week. We played around with being able to take in specific inputs. Um, and so in this case, we want your meatball function to take into input food that modifies. Instead of saying I lost my poor meatball, it's I lost my poor food, right? Whenever that food input is. And then modify the wrapper function um, uh, within the spaghetti decorator. Remember, there's that wrapper function. The wrapper function is going to take in a flexible amount of arguments, right? Remember that shorthand, that args, which takes in a tuple and then allows you to then invoke that properly. So just kind of modifying it to deal with that. Then, let's see, modify your previous meatball wrap function to be a class method for a class of song, right? And it should be, so now this is a song. You should be able to create a song object and then invoke that specific thing where you have object, meatball, food, and then it should be able to print that. So, um, yeah, so that's going to be the first thing, again, dealing with decorator. Again, this is stuff from last week, but just to kind of a quick refresh. Static versus class methods. So again, so this is going to be, I think, so this is going to be a static method. So first a math utilities method. A math utilities class include a static method add that just takes in two inputs and returns the sum of it, right? So again, I should, and remember, I don't need to, because it's a class method, I don't need to create an object in order to utilize it. So I can reference the class directly, in this case, math utilities add, and I should be able to get the result. So it's a static method. Then I'm going to do sort of a class method. So first, in order to do that, you're going to create a customer class. So the customer will have a class level attribute called count, which will be initialized to 0. So you have a class attribute, so just going to be count, not a self.count, but just a count equals 0. Then you will have a constructor that defines an attribute based on input and also increments the customer count attribute by 1. So define get count. Yeah, and then define a count, get count. Oh, you got it. Okay, so wait a second. Do I want you to? Oh, I guess. Oh, so I guess the constructor isn't the class method here. I think interesting. Really? I'll have to take a peek at that. But I guess the way I have it here, the constructor itself isn't a class method. The class method here in this terms is a get count. It's a class method because it returns the count. So it's a simple getter. So it's not a setter. That's interesting. I didn't realize I have this set up not a setter. But maybe you can just do a constructor. Um, yeah, interesting. Okay. So yeah, so you have your basic constructor that in addition to initializing with, the attribute for customer, it also will increment the class thing by one. Um, and then again, supposedly that doesn't have to be a class method. I'm a little suspicious of that, but the way I've written it, I guess you don't have to. But again, you ultimately will do a class method. The class method is going to be a get count, and that's just going to return the class attribute itself. So that's going to be, again, those are all things we did last week, decoration, stack versus class methods. Stuff we did today is encapsulation. So, okay, so using our ATM exercise as an inspiration. So again, so we're going to now sort of play around with that idea in I think a really applicable way. So we're going to create two private attributes, name and balance. So the class should provide getter and setter methods, get name, get balance, set balance, to access and modify these attributes respectively. So this encapsulation should ensure that attributes can only be modified through these particular methods, right? That's what we were talking about. The setters, you should only be able to modify a private attribute through the setters of the class. And again, that sort of allows us to control it. Um, then you can create a savings account class as a subclass of account, right? So you have an account class, and then you create a savings account subclass, and just have it directly inherit those private attributes. So no modifications needed. So and again, you'll see here in the test cases, you're going to create an overall account here. You can see a get name, get balance. You're going to modify using those attributes to modify those as well. And then you're going to sort of test around those. Again, you're going to test around the inherited account as well. Um, so now we're going to make some slight modifications to that. So the previous account class now, we're going to modify name and balance to be protected. So they're not going to be private anymore. They're going to be protected. Were these private? Yeah, see, two privates. Yeah, so these were both started as privates. We're going to change them to be protected. And so now we're going to modify subclass, savings account, which again is a subclass of account. The subclass should add a new protected attribute, interest rate, should define its own getters and setters for it. And so now, right, so we're going to get a little bit of, I think, a polymorphic thing here, because we're going to do a set balance on the subclass thing. That's going to be different than the set balance for the class. So the set balance here modifies, is going to update the balance using basically an interest rate formula. So you're going to take your current balance, you're going to increment it by whatever the interest rate is and apply that to the interest rate. So you're going to see here, right? So in this case, I'm now going to I'm going to create a new savings account object where I'm going to write Carol, balance is 1,500, interest rate is 5%. Then I'm going to set balance to update it using this specific subclass protected method. And it's going to do that. So that is what is being asked of you for lab 3. Any questions on that? And sorry, I know that was a bit of a long-winded description, but yeah, let's talk it through. Any questions on what's being asked of you? No, you guys feeling okay about this? All right. Okay. Well, so as promised, that's again all I wanted to cover for tonight. So I'm going to end the lecture on there. Again, I'm going to stick around. Again, just stick around here if anybody has any additional questions. Want to talk through some of the labs if in case you guys are stuck on anything and just provide you guys with a little bit extra support. If you're feeling good though, if things are good, then you are more than welcome to drop for the evening. Have a great week, and then again, when we come back next week, we're gonna start on module three. And depending on how ambitious I want to be, we may just actually just kind of march through module three, and we might just get like there's two parts to it. It's pretty simple. We might just get through the whole thing. I'll see. I'm gonna we'll see. Particularly, we'll see on how y'all are doing with all the work. But it would be kind of cool if we can kind of get module three done before spring break. I kind of like to do that so that when you come back from spring break, we get to start fresh. We get to start talking about GUIs, which I don't know about you, but I'm excited about GUIs. That's a fun. That's a module I'm looking forward to. So, all right, end the recording there, and